to talk about in this session, it's called Building a Secure, the name of the real session is Building a Secure-by-Design Industrial Internet of Things. I titled my slides, I skipped a few so it would fit, but anyhow. So what we're going to be talking about is this emerging thing that we call the Industrial Internet of Things, and there's lots of different names for whatever that is, which I'll get to in a minute. And clearly there's going to be some emerging security issues, and so that's what we're going to focus on in this presentation. And actually, so when I said presentation, but now let me mention about the session. What we ended up doing with this session, because the Industrial Internet of Things is rather emerging, you know, it's a very new topic, and really I didn't think we could find use cases to have a traditional ARC session where we had, like we had the last one, where we have a couple presentations by users followed by a panel discussion. Instead, this session is primarily going to be a panel discussion. I'm going to give a presentation to frame the issues, and then we're going to have the rest of it as a panel discussion. So I need all your support with lots of questions out there. When we get to the panel discussion, and the other point I want to make about this session is normally at ARC we always have restrictions as to who speaks and does stuff like that and who participates on panels. And this time, and often we have a panel where we'll invite all end users, because a lot of people like to talk to end users. In this one, it's a panel of suppliers of different services or products. And the reason I did that is, again, because it's an emerging situation, that a lot of the things we're going to talk about is really at the forefront of what's going on, and I thought that's the best people to talk to. They're the ones that know what they're doing and where they're headed. So I just want to make those points at front to begin with. Now I hope I can use this arc. We have a mouse that we've used for years. Every year I come here and it doesn't work. So anyhow, hopefully it works today. So anyhow, what I want to do, I have this presentation. The point of the presentation is just to frame the issue. And what I'm doing is, it's really based upon a report that I wrote last fall that I called The Future of Industrial Cybersecurity, which really addressed what we see as changes happening in the automation space or in control world. The Industrial Internet of Things is one of those key factors, but we think it's really changing the nature of control systems, which is then going to change the nature of what I think we today call ICS Cybersecurity. And by ICS, I mean Industrial Control Systems Cybersecurity, for those that don't use that term. So what I want to do is talk about how we see, what we mean by the Industrial Internet of Things, what's the implications of that for industrial control systems, what's the implication of the changes in industrial control systems for cybersecurity, and then what kinds of things need to be done. And then when we're done with that, we'll go to the panel. I'll invite up, we have a very distinguished panel of people. I'll invite them up, and someone else. That was a little inside joke, sorry. I'll invite them up, and then we'll ask some questions. I'll lead off with some questions and then open it up to the floor. And I hope you have a lot of questions. So with that said, there we go. So the first question is, what is the Industrial Internet of Things? Now, I believe my boss, Andy Chadha, in his presentation this morning used that slide. He was going to. I'm not sure if he actually did. But what it is a typical use case. It's one that we've talked a lot about, and I think it's a very popular use case in the industrial control world for what one might call the Industrial Internet of Things, or again, it might be the Internet of Things or the Industrial Internet, Internet 4.0. There's all different names that are being used for certain things. But the basic use case that this one is capturing is the idea of remote maintenance, remote support type of things. And the idea is that you're going to add a lot of sensors, instrumentation that you would not have added to the site, to equipment in the site, or outside the site. I make that point there. But these are assets, these are systems or sensors that are smart, that communicate through different channels, and the primary purpose is to get the information to somewhere else, not necessarily in the plant. It's just not adding sensors, it's taking information and getting it outside the system to some central maintenance system that somebody might have, or maybe your vendor has. They provide remote service, things like that. So if you look at that structure that I show right there, you know, the blue was the control system, and it's a traditional kind of picture for a control system, a couple levels, the Purdue model. And then we show a smart card to the right of that, which would be an IoT sensor of some type, and something intelligent with some communication. Generally, they communicate through some other kind of a network because people don't want to connect. One thing we find, by the way, one big difference with connecting sensors in IoT is a lot of people don't want to connect sensors to their control systems because it's actually a lot more expensive. You know, you have to put in I/O cards, you have to do a lot of other stuff with I/O to add the sensors. So some people are looking at it almost like the idea of wireless sensors, but they're using it separately, but then they generally want to bring that information through another channel, another secure thing because of where it's going. And there's different models for this, different people. Some people will collect the information within the plant and then send it somewhere else securely. Generally, the information is sent to a cloud system of some type. The reason there's a cloud is because the cloud's there to share the data, to maybe do some applications with the data, maybe do analytics with it. We talk a lot about analytics and things like that. And then you see, then maybe you might have multiple suppliers sharing the same information and stuff like that. So that's one version, and that's a very common, very popular strategy, I think, or when people talk about the industrial Internet of Things. If you read, we have a report at ARC that somebody else wrote last year, maybe a year and a half ago. That's the model that they were talking about. So that's one view of that. And in a way, I think that's an important one, but you notice it's kind of a controlled one use case. And if you're going to design for that, that's one thing. Another slide that I believe Andy used this morning, well, he didn't use that slide, but that figure, I believe, was in his slides. And we call it the connected enterprise. And if you look at that picture is intended to talk about having all kinds of sensors all over the place remotely, Internet of Things, that you use in all kinds of business processes to improve the performance of those business processes. That includes things like supply chain. It might include things where you add sensors on the products you make, you know, the Caterpillar example, where you sell the product and then you sell service with it, so you're collecting information. It can connect with operations. But in any case, there's lots of devices all over the world, or all over the place, not necessarily in plants, and they're feeding back to some type of cloud platform again. And in the cloud platform, you have certain features, which would be something to manage the devices, manage the connectivity. Notice security is mentioned in there, but it's really, the person who wrote the thing was focusing more on cloud security. And then you might have analytics, big data analytics. You may even also have some applications. Now, this one to me is a much more open kind of an environment, all right? It's like saying everything's completely open now, all right? Now, those are kind of two extremes, I think. But if you look at the two, the elements I want to focus on, the elements of both of those scenarios, or those paradigms, that are relevant to today's talk that I want to focus on, constrain to talk about or let it talk about, is three elements. First thing are the things, okay? And I'm using the term smart autonomous devices. You can call them whatever you like to call them, but they're some type of a device that has intelligence in it that also has the ability to communicate back to somewhere. And generally, those are going to have like a Wi-Fi connection of some type. It could be cellular, it could be other kind of connections, but it's something that's could work on public networks. When I say public, on the internet, let's just use that term. You might do it securely through the internet, whatever, but it's connecting in that kind of a world. The second element is what I call, somebody gave me this terminology, I like it actually, ubiquitous connectivity. You know, it's this fact that you're going to be connecting anything, it's the anything, anywhere, anytime kind of a scenario, except I'm not talking about a mobile device. I'm talking about a PDA type device or something. This is some type of a sensor that might be on a truck that's moving around. It might be in a car. It could be in any kind of thing. But the issue the point I want to say is that another element is that connectivity. And I also throw mobility in there too, because I think it has to support mobility a lot these days. And then the third element is cloud computing, okay? And by cloud computing, what we see, and this is one thing I expand the discussion into. We may or may not get into that today, but one thing we see happening in control systems is people are talking about adding sensors and doing things like that, but also we see applications that are traditionally within an industrial plant being moved to the cloud. It could be a historian, it could be an advanced process control algorithm, but people are starting to take advantage of cloud applications. So that's now taking the inside of the plant and moving it out into that dangerous world, okay? So those are the three issues, I think, and if you look at those three topics, the next question I have in my mind is, so what's that mean for what we call industrial control system cybersecurity, all right? Or what does that do for what we might call an industrial control system? Now this picture here comes straight from IEC 62443 spec. And what it is the standard configuration I think that any engineers in the room is very familiar with for a layout of a plant. And this one happens to have 3 plants, plant A, plant B, plant C, connecting to some enterprise system. And if you look at it within those purple, or whatever that color is, boxes, you know, you see a typical multi-layer control system, a Purdue model. Again. I always say Purdue model. I guess I date myself, but when I started it was Purdue models. And notice that they have kind of well-defined perimeters around them. And there's firewalls that block what goes into that perimeter. You may have a DMZ, you may not. Then there's firewalls within that goes down into the control networks. If you have multiple zones, those would be zoned and things like that. So that's the problem that the IEC 62443 spec is trying to solve. Now, there's also the SCADA version. I just did this one picture for plants. You also have a similar kind of a thing for SCADA. But it's kind of like when you think of what people were saying, we're going to say how you should manage cybersecurity, you have to start off by saying, what is it you're managing? And this is what we were managing, or are managing, I think, in today's world. Now, that's today's system. So when you think of all these technologies I talked about, the smart devices, the cloud, the ubiquitous, I love that term, ubiquitous connectivity. It wasn't mine, all right, but I like that term. When you take all those together, and now you say, what's the future look like? Now, I threw one together for oil and gas, and I think it's probably an exaggeration to a certain point. It isn't going to happen tomorrow. But if you look at it, you know, on the bottom you have plants, you have factories, you have remote operations platforms and things like that are out there. You could have in-plant or outside the plant type devices. That might be working pumps and things like that along a pipeline, completely independent type units. You may have remote gas tanks, you know, gas distribution at retail sites. On the other side, you're going to have cloud applications, mobile devices. You have enterprise systems. You could even throw in there smart cars. You know, this scenario of the car drives up to the pump and says, I use this kind of gas, you know, that kind of a scenario. But when you think about it in the future, all of that stuff's going to be interconnected or enable people to share information. That's kind of the issue, I think. And in the middle, I show it all coming through some type of ubiquitous connectivity again, which maybe I should just say internet, and with some kind of cloud services probably tied in, okay? Now that scenario, by the way, just a comment, it's funny, I don't know who else saw this, but there was I look at all the cyber report kind of things, but anyhow, there was one recently on the gas tanks. There's a gas tank control. Now what it was for is the tanks I think maybe at a terminal where it automatically dispenses the gas to the trucks who deliver it to the stations. But someone found a vulnerability in that, all right? So, but the fact that it's there raised the point again that is already being done remotely, all right? And somebody found a vulnerability, a security vulnerability in that whoever system it was. So it's already there. But anyhow, now if you look at that environment, to me again, if I say to you now, your security job is to protect that, that's quite different than what I think we're talking about today as ICS Cybersecurity. Some people might say, well, all I'm going to focus on is the plant. Okay, but I don't think that's the reality. I think the reality is if you work for an oil company, you have to deal with all of those things. They're all interconnected today. So to me, that changes the game. That's the landscape I'm picturing. And again, maybe it's a little exaggerated, but it's something to frame the issue, okay? So I'm talking very general, and each of you can discuss it, and probably everybody here has a different view of what the industrial Internet of Things is. Now, if you say that's the new control system, in a sense, that you have to manage, then you have to say, well, what happens to the cybersecurity aspect? So this little slide was just the technology developments cause changes in the control systems cause changes in the cybersecurity challenges that you have. And to me, the major impacts I think that happened from that is, first of all, I think, you know, the attack surface just explodes. You've got things all over the place. Now, it's not just protecting your plant. I mean, you've got them all over the place. So you have this exponential increase in the attack surfaces. At the same time, I also think that you're going to get an increase in the likelihood of getting an attack. I was talking to people, and you know, one thing is to say, they'll say, well, who's going to attack my little plant over here? Why would they do that? But all of a sudden, if all of a sudden you put some of your control apps up on the cloud, Clouds are worthwhile attacking for people. A little plant might not be cost justified to a cyber criminal or a terrorist or someone like that, but to attack a cloud system and hit a lot of plants, that has appeal. So I think the likelihood that someone might attack you goes up. And then, most importantly, I think your ability as a company to control the cybersecurity goes down. Because now it's not up to you. You know, we had the previous panel, we were talking about managed services, and people are outsourcing the services. But they still have control of what they're managing with that company. And they're hiring a lot of times their ICS vendors. But now you have to deal with cloud service providers, your internet service providers. You have all kinds of people that have to manage security. So you lose the ability to control it yourself. So when you get down to it, when you look at that, this is a little chart I like to use when I talk about strategy. You know, when we talk to companies about strategy in general, like every analyst, I talk about people, processes, and technology, and the scope and mission and things like that. And I don't want to dwell on this slide. We could talk all day. But I think the nature of the problem changes, and the kinds of strategy have to change. You know, you're not just protecting plants anymore. Now you're protecting plants plus a bunch of devices and things like that all over the place. I think that another key one there, I don't want to read all of these things, but if you get down to processes, you know, today people are focused on, and a lot of people I talk to, their primary strategy is to block at the perimeters, keep things out of the networks. The second thing is then, you know, have some protection at the end of devices for USBs and things like that. Those are their two focal points, okay? But so they're managing the security at the perimeter and the security of the networks and maybe the zones and things like that. In the future, when you start putting devices out there, you have to have devices, in my opinion, that are secure at the device. You can't worry, you're losing all those boundaries, the ability to put it into a secure zone and things like that. You have to have secure-by-design devices. The other thing is when you talk about the networks, you have to not just say, I'm going to put firewalls and make my network internally secure. You now have to think all those messages going out in public networks and everything else. You have to deal with that. Maybe you can do it with encryption, maybe not, but you have issues external. All right, I think, I don't want to dwell on that slide. I'd be here all afternoon. As you could tell, I like to talk. So those who know me know that only too well. Another way to think of this, so anyhow, I think those are major changes, but another way that I know is popular, and I like as well, is I hear it all the time now, ITOT. In a way, I don't like it because for analysts, that was a Gartner thing, ITOT. And they're coming from the IT world, and they call it OT. You know, whatever we do is OT, which I don't mind. I like the term. It's just I don't know that they understand the depth of the term. Okay, enough criticism of Gartner. But if you take that paradigm, I think that the issue we have is a little more than that. It's two-dimensional. One is IT and OT. You know, IT being things used for business systems and things like that, typical enterprise systems, OT being things used for industrial purposes in my definition right now. But then we also have to deal with devices and systems, and I think those are different security issues. And if you look today, I don't want to hurt, our laser doesn't work, I don't think, but if it does, I would blind someone, so I'm not going to use that. But if you look at the upper left corner there, that's what we've constrained the world of ICS cybersecurity to be today. Industrial control systems. That's the focus. I'm not criticizing, I'm just saying that's the focus. Tomorrow, you got to deal with all of those boxes. We have to deal with enterprise systems because you're going to have apps outside your operation that are important from the corporation's point of view. You're going to have to deal with intelligent assets. I also threw in mobile devices because I think too, you know, as we all know, you walk into plants and everybody's doing stuff with mobile devices now, and you have to worry about a maintenance person comes in with a mobile device that wirelessly connects to a sensor, to a device. You know, not necessarily through the control system, it just connects to the device and tests it. So you have a lot of pathways. And then in the middle, you have this ubiquitous connectivity and everything. And then I think my last slide is this one right here, which is just, when you look at it from the security strategy perspective, there's a thing at that upper left corner that I would call ICS Cybersecurity. But when you go to cover all those boxes, you start having to really integrate. You know, what I see as an analyst when I talk to people, there's still, there's always this IT versus ICS cybersecurity, and most companies will have some boundary, you take care of that, I'll take care of this, and maybe they overlap a little bit, like maybe IT takes care of the historians or something like that in the DMZ. But there's that separation. And I know we've been saying for years, and I know other people have too, is you have to do more integration. Now I think you really have to think about integration, integrating programs. And it's not just IT/OT, it's IT/OT, mobile device security, third-party cybersecurity. How are you going to manage the security of a cloud service, for example? And when I say that, it's not that, that anybody would expect you to manage it, but you have to make sure that that cloud service provider has the same risk profile that you do. I mean, he has to consider things as seriously as you do, or at least be consistent with yours. So I see it as this integration. Now, that was what my presentation was to frame the issue. Hopefully, it blew up the issue. I didn't focus it down, I expanded it, but that's fine, that's good. That's what analysts do. My job is just, I'm classic, this is your problem. If you have to boil the ocean, that's your problem. I don't give you the answers, I just give you the problems.